I'm sorry, I got interrupted and I pushed stop instead of pause. Sorry. Okay, so taking off where we were, here we go. We're finding the area with 3 subintervals with left endpoints, and we end up with 16 plus 32, which is indeed, what is it, 48? 48. Now, we knew ahead of time that this was going to be underestimating this area. And you can tell it's pretty way under in terms of estimate. Now they want us for C to estimate with 3 subintervals, but with right hand endpoints. So instead, I've got these 3 blocks. Right endpoints means I'm now going to actually go from here to here, from this point here to here, and from this point here to here. Now this should actually not surprise you that we're going to overestimate at this point. So when I find the area, the base is still 2, but instead I'm actually finding, this is my first u value. This is u sub 1, u sub 2, u sub 3, right? This is my first endpoint, which is going to be f of 2 times the base, plus f of 4 times the base, plus f of 6 times the base. So we end up with f of 2 is 8, so we have 8 times 2, plus 16 times 2, plus 24 times 2. And when we do the quick calculations, we get an overestimate, which shouldn't be shocking, of 96 units. Now, if this one's kind of interesting because this is a kind of a static function, that the average of these two is indeed 72. But this is all about process and teaching you how to do this. I'm just going to do D, not E, and that's what I did in class today, just due to the time. But now for D, they want 6 sub-intervals with left-hand endpoints. So instead of these, do a little erasing. Instead of 3, I'm now going to have 6 sub-intervals. Now with 6, I should be getting closer. So left endpoints, here's my first, here's my second, third, fourth, fifth, sixth. I'm finding these areas now. Probably should have used different colored pencils. Again, it's going to be an underestimate, but do you see how there's actually less? We're getting closer and closer than our original one when we did left endpoints. So once again, right, we're going to end up, to find the area, we're going to take the function f of 0 times our base. What is our base now? Each one of these is 1, right? So now we're going to actually be multiplying by 1. So the function, when we plug in 1 times the base, times the height of f of 2 times the base, right, times f of 3 times the base, plus f of 4 times the base, plus f of 5 times the base. And when you calculate that, right, this is going to be 0, plus f of 1 was 4 times 1, plus 8 times 1, plus 12 times 1, plus, 16 times 1, plus 20 times 1, and you come up with, what is that, 60. We're getting closer. Okay, so it should make sense that as we do more and more intervals, our approximations are going to get much closer to our actual. Oops, and I'm sorry, that was kind of hard to see. I'll move that up. Okay, now what I want to do is give you a little bit of generalizations. We're almost done, and help you with the notation that this book offers you. Okay. So, in general, let's talk about that. In general, and we're almost done. In general, here's kind of how you deal with finding the area. These are called area problems, okay? The first thing is that what you're going to start with is you're going to partition the interval from A to B into n equal subintervals. So you're going to choose an n amount of subintervals, okay, of equal length. Now we use the symbol delta x to represent these equal subintervals, meaning the distance, and I'll shove this down, this would be delta x, pretty much the base of these rectangles. I keep saying triangles. The base of the rectangles. So delta x represents the base of the triangles, which can be found by taking b minus a and then dividing by how many rectangles you actually have, how many sub-intervals you're actually doing, okay? So that's the first step. Then the second step is you're going to form rectangles. You're going to form rectangles with base delta x and height f of u, and I'm going to put u sub I. What I represents here, this u sub I, is how many i's, how many u's you actually have, depending on how many intervals. I's usually start with 1, 2, 3, 4, 5. So it's like they're the integers of how many u values you have. So the height is when you plug in, the actual first value from your endpoint. Okay? Then the third step is you're going to add all the areas, add up the areas of the rectangles, and that's going to look like, right, f sub u sub 1 times delta x, right, the first function times the base, plus the second function, the height of the second rectangle times delta x, the base, plus dot dot dot, keep continuing until you get to ultimately the final oops, let me raise this up, the final subinterval times the base. Okay? Now if you see this is a sequence, right? We could actually, this is an arithmetic sequence that we can actually combine and write in summation notation, saying that I've got this function, right, taking the height times the base, and I'm going to go up to n subintervals starting with the first number. Now, what's really cool about this, right, so this is just saying we're going to take, this is finding the area of these rectangles starting at 1, going up to however many we have. Now, can you imagine that if the intervals increase, right, so n's talking about how many intervals, if the intervals, the subintervals increase to 10, 100, 1000, now our approximation, right, is getting, well, n is getting infinitely larger, and our approximation is ultimately going to be the actual area underneath the curve. So here's what I want you to write. If the limit as n approaches infinity, I don't know if you can see that, if the limit as n approaches infinity of this summation that we just wrote exists, okay? If this exists, then it is defined as the area under the graph from A to B. Okay? Now, the limit, as we continue to get increasingly larger, then this approximation becomes the actual area under the graph. Now we use fancy notation for this, okay? And here's the fancy notation, which I'm going to show you right now. The fancy notation that you will meet looks like this. I'm going to write new symbol. The new symbol looks like this. It's like this big old stretched out S, and it looks like this. This is read as the integral. Here's the integral. The integral from A to B, from A to B of f of x. This symbol right here, this integral, this is the integral, represents the limit as n approaches infinity of all the areas of all those little rectangles underneath the curve. So really what the integral is the area underneath a graph of a function. Okay? So the last example I'm going to show you is how to use your graphing calculator. So this is using calculator. They're going to give you something that looks like this. From 1 to 3, the integral from 1 to 3 of negative 2x plus 7 dx. Okay? And here's how you do this on the calculator. You're going to hit, and I'll write it down and then I'll show you. Go to math. Okay? Under the math button, hit number 9. Number 9 looks like f of n integral or something like that. Hit that button. So then that's going to pop up. You're going to have something that looks like f of n integral on your calculator. Okay? Then it's going to have parentheses. Then type in your function. So I always like to do sometimes double parentheses to be careful. I push in my function, comma, x, comma, and then what your A and your B from whatever values, your intervals. So from 1 to 3. So 1 comma 3, close parentheses, hit enter, and you'll get that this actually equals 6. And what's pretty cool is that if you were to actually graph this, for example, so here's 1, 1, 2, 3, I'm looking from 1 to 3, and I've got the graph, this is a y-intercept of 7, 1, 2, 3, 4, 5, 6, 7, here's 7, and I have a downslope of 2, 2 over 1, 2 over 1, 2 over 1. They're asking me what is the area of this guy right here. This is really what they're asking me. What is the area from 1 to 3? Here's my function, negative 2x plus 7. What's this area? Well, I know this is 2, right? And this is a trapezoid. I know this is 1, and this height is 5. So area of a trapezoid is 1/2. My bases added together times the height. So I've got 1/2 times 6 times 2, which is 6. And there you go. Okay, so on a calculator, show you real fast, and then we are done. We're going to go into second math. Not second math, just math. See if I can show you this. Go scroll down to number 9, or you could just hit number 9. There's number 9. Fn integral. Hit enter. And then you're going to punch in your function. I'm going to use extra parentheses. Negative 2x plus 7, close parentheses, comma, x, comma, from 1 comma to 3, close parentheses, hit enter, and there's my integral 6. All right, the assignment itself, I will give you right now. The assignment is, and I'll put it right here, is page 944, numbers 5, 7, 9, 15, 17, 21, 25, 27. Email me over the weekend if you have any problems, and we're going to go over this on Monday. Good luck!